So students, after discussing about the physical quantities and their SI units, now let us discuss about an important thing, that is how to write the unit with a physical quantities. So basically we are using the following sign conventions in order to write or assign a unit with a physical quantity. The first one is, if we are writing a unit named after a person who gave that unit, in that case that is written in small letters, not in capital letters. That is, if we are assigning the unit joules to work or energy, in that case J in that joules will be small, not the capital. Second one, for a unit named after a person, the symbol is capital letter. That is, again for joules we write capital J instead of small j, and the rest of the units with this unit will appear in lowercase. For example, if we want to write down for work done, we know that work done is force into displacement. In that case, the unit for work done will be joule, and if we are writing the unit in terms of Newton and second, in that case the unit will be capital N and the displacement that is in meter. So here the unit is Newton meter, but N is capital, but M, that for meter, is small. Now the symbols of units do not have plural form. Here we are having example that 70 number is plural, but the unit assigned is singular, that is meter. We are writing it as 70 meter, not 70 meters. In that case, M and S, they are meters second, not meters. Or 10 Newton, not 10 newtons. If we are considering it as newtons, in that case N into S will be the unit for some other physical quantity. And the next rule is, the punctuation marks are not written after the unit. If we are considering, for example, 1 liter, in that case we know that 1 liter is 1000 cubic centimeter, so it is written as 1000 cc, not 1000 c dot c dot. So these are the sign conventions or some important points in order to assign a unit to a given physical quantity. Now there are some other units also we are using in general, like the minutes. 1 minute, you know, that is 60 second. Hour, that is 1 hour is equals to 60 minute, that is equals to 3600 second. 1 day is containing 24 hours, and there are so many other general units we are using for different physical quantities. Now after discussing the sign conventions and the units for the physical quantity, let us discuss about how to measure these physical quantities out of the length, time, mass. Let us first discuss about length, how the length is measured for a particular object. Now the order of distances, we know that varies from 10 raised to power minus 14 meter, that is of Fermi order, to 10 raised to power 25 meter. Now this 10 raised to power minus 14 meter is the order of the radius of a nucleus, and the 10 raised to power 25 meter is as large as the size of the universe. So we are considering the methods in order to find out or measure these length. Now the distances measured from the 10 raised to power minus 5 meter to 10 raised to power 2 meter, they can be measured by direct methods, which involves comparison of distance or length to be measured with a chosen standard length, like 10 raised to power 2 meter with the help of scales, 20 raised to power minus 5 with the help of instruments we are having in our lab as well as. So for example, we can use a meter rod to measure a distance 10 raised to power minus 3 meter, that is 1 millimeter, that is given on a given meter scale. Again, an instrument known as vernier calipers is used to measure the distances of the order of 10 raised to power minus 4 meter, and screw gauge is used to measure a small distance of the order of 10 raised to power minus 5 or 10 raised to power minus 6 meter. So these are the instruments we are having in our lab also, that is a meter rod, a vernier caliper, a screw gauge, and you are going to perform experiments in order to measure various length using these instruments. Hence, for small distances or very large distances, indirect methods are used. That is, distance smaller than 10 raised to power minus 6 meter and greater than 10 raised to power 3 meter. So let us first method in order to find out the large distances, that is measurement of large distances. So first method in order to find out the large distances using the indirect methods is the parallax method. And you are aware of this word, what parallax is. When we are observing anything with one eye, that is opening one eye and closing the other one, we see a position for that object. But if we close the given eye and cover the another one, we see that the object is being displaced from its previous position. So this is known as the parallax method. For this, let us consider an object, that is a planet, which is far away, and suppose the distance of that planet from our two eyes is capital D. Now let us consider that here you can see in this figure that P is the planet and L is our left eye, R is our right eye, and D is the distance of that planet with these two corresponding positions. Now let us imagine that the line joining the planet to the left eye and right eye, they make an angle theta with this planet P, and here is the theta, and small b is the distance between these left and right positions. So theta is in radians, that is SI unit for theta angle. D is in meter, B is in meter. So here this theta is called the parallax angle or parallactic angle, and the distance, this L and R, that is LR distance is B, and this is called the basis. Now as we know that the planet is far away, so we can ignore this B by D, and let us take that this is very less than 1, that is nearly equals to 0. So here we can imagine that theta is very small, because this distance B between the two positions for left and right eye opening is very small as compared to the distance of planet from these two positions. So let us take that LR is equals to B and a circular arc of radius D we are having. So substituting the values, we are having theta is equals to LR by D, putting the value of LR and D, and if we know the angle, in that case we can easily find out the distance D as that capital D is equals to B by theta. So B is known, theta is known, and in this manner we can easily find out the distance of planet from us. So in this manner we can use this parallax method or as an application in order to find out the diameter of an astronomical object. So let us find out or measure the size of an astronomical object. So in that case, let us consider a planet whose diameter is d, and we are standing on Earth, and this planet diameter is at distance d from an observation point on Earth, making an angle alpha with the diameter. So if d is the diameter and alpha is the angular size of the planet, that is the angle subtended by the diameter at the Earth, in that case we are having alpha is equals to d by d, that is small d by capital D, and this angle can be measured from the same location on the Earth. So it is the angle between two directions when two diametrically opposite points of the planet are viewed through the telescope. Now, as d is known, the distance of that planet from the Earth, the diameter of planet can be easily find out using the relation d is equals to alpha d. So this parallax method can be used in so many ways in order to figure out the things about the astronomical, that is the celestial objects. Next indirect method is the echo method or the reflection method. This method you had already studied in your previous classes as well, that is in sound chapter in your 9th class. Now this method is used to measure the distance of a given hill. So you know that when we make a sound for a minimum range or the distance, we can easily get an echo, and that is due to the reflection of sound. So we can measure the distance using this echo method, and we know that the minimum distance required to produce an echo of sound is what? That is 17.2 meter between the obstacle and the source of sound. So let us consider an example that we are having a hill and we are having a gunfire, and the gunfire sound is being reflected through that hill and echo is received. Now the distance between that person who is firing the bullet through a gun is capital S, and the echo received by the same person is again covering the same distance, that is capital F. So the gun is fired towards the hill, and the time interval between the instant of firing the gun and the instant of hearing the echo of the gunshot is noted here. This is the time taken by the sound to travel from the observer to the hill and back to the observer. Now, if v is the velocity of sound and s is the distance of hill from the observer and t is the total time taken, in that case, we know that velocity is distance upon time, distance is twice of s, and time is t. So we can apply that formula of velocity and figure out that the distance between the person and the hill is v into t by 2. So again we can use this echo method. There are so many applications of this echo method. That is, we can use this method in order to place sound waves. Laser can be used to measure the distance of moon from the earth. So laser is known as the monochromatic source, intense and unidirectional. So this echo method is again used over there. Now let us discuss about the range of length. Now the size of object we come across in the universe, it varies widely. Like we are having the distances of the order of the Fermi level, even less than that, and of the order of the universe. So the range can vary from as small as 10 raised to power minus 15 meter to 10 raised to power 26-27 meter. So in order to discuss the distances, let us have a look over the short and large range distances we are dealing with in our day-to-day life. So in the first column we are having unit, second we are having the symbols, third the values and their definition. The smallest known is the Fermi, and 1 Fermi is equals to 10 raised to power minus 15 meter. 1 angstrom we are using in our numerical as well, that is 10 raised to power minus 10 meter. Astronomical unit, that is a bigger unit. So 1 astronomical unit is 1.496 into 10 raised to power 11 meter, and this is the average distance of the sun from the earth. 1 light year is 9.46 into 10 raised to power 15 meter, and the distance that light travel with the speed of light, that is 3 into 10 raised to power 8 meter per second in 1 year. So this is the distance traveled by light with this speed, and it takes 1 year. So this light year is basically the unit of length, not the unit of time. Parsec, this is the bigger unit even, and its value is 3.08 into 10 raised to power 16 meter, and this is nearly equals to 3.26 light years. And this is the distance at which average radius of earth orbit suspends an angle of 1 arc second. So we are having a long range of the distances, and we are having so many other methods in order to find out these distances. Like we use electronic microscope in order to find out the small length, that is of the order of microns and nanometer, and we are having the Avogadro method again in order to find out the small radius of the atom, that is of the order of 10 raised to power 9 minus 9 meter or 10 raised to power minus 12 meter. So far we had discussed about the methods to find out or measure the length and distance of the heavenly as well as the small objects. The range and the order of length having a varied values, like the size of proton is of the order of 10 raised to power minus 15, and the thickness of paper is nearly equals to 10 raised to power minus 4 meter. The distance of moon from earth is 10 raised to power 8 meter. So now you can imagine the varied variety of range of the length we are having in our world, or we can say in our universe.